Okay, so here's the homework for the week. My email's at the top. If you have any questions, you can ask. But your grade can't go down no matter what. Uh, there's a possibility it could go up. What I was thinking is if you do the majority of the work, so like well over half, turn it in whenever you can, whenever we get back. Uh, I can boost your grade up one letter grade. Now, there could be a directive that says we can't do that because of equality, but if there is no directive, I don't have a problem raising your grade up one if you did a lot of the work, but I can't guarantee you that. If someone above my pay scale says that we can't. So anyways, this is more for your future than your grade. But like I said, your grade definitely can't go down, possibly could go up, but I can't guarantee you that. All right, so there's my email. So my goal is to get through 4 lessons during this time. All right. The first lesson is on box plots. With the box plots, what we have to do is find the 5-number summary first. The 5-number summary consists of the minimum, Q1, Q2, which is also the median, Q3, and the maximum. Min and max, I think we have a pretty good idea. Q1 represents the first quartile. Q3 represents the third quartile. To do an example, say the minimum is 1, Q1 is 4, Q2 is 6, Q3 is 9.5, and the max is 15. And we want to make a box plot. The number line has to have equal intervals. You do not have to start at 0, but we do need to have equal intervals. Looking at the min and the max, we notice start at 1, we end at 15, so we could probably go by 1s or 2s. You want to try to have 6 to 12 marks, but that's not a rule. So I'll just go by 2s, starting with 1. 1, 3, 5, 7, 9, 11, 13, 15. Did not have to do it this way, but this is just one way. The key again is making sure we have equal intervals. The box consists of the 3 Qs. So we put a line at 4, a line at 6, and a line at 9.5. Those are the Q1, 2, and 3. I will label them above it. You don't have to, but just to show where these numbers came from. That was the Q1, 2, and 3. And then we draw a whisker, sometimes referred to the biggest and smallest number that are not outliers. We will talk about outliers later, but for right now, we'll just draw it to the min and max. And there's your box plot. The box represents 50% of the data from Q1 to Q3. The upper quartile, or the third quartile, is the higher 25%. And then the lower quartile, or the first quartile, is 25% also. If a graph looks the same on both sides, we call that symmetrical, or this box plot is symmetric. If the majority of the data is on one side, say it looks like this, this would be positively skewed. If the data is on the other side, towards the right, we would say that is negatively skewed. If the data is bunched together, let me just draw both of these at the same time. So both these graphs have the same min and max, but you can see the rectangle looks different. We can even say they both have the same median. But the top graph, the graph that has a narrow rectangle, we would say the numbers are bunched together. In the middle. Where the bottom diagram, we would say the numbers are more spread out. All right, let's do an example. We have 3, 6, 9, 10, 16 numbers. 4 2s, 2 3s, 4 5s, 3 6s, an 8, and a 12. We want to construct a 5-number summary. It doesn't matter which order you do these in. The min is obviously 2, smallest number. The max is 12, the biggest number. To find the median, most people will do the slash method here. So you slash out till you get to the middle. If you have 2 in the middle, we have to take the average. The average of 5 and 5 is obviously 5. 5 plus 5 is 10, divided by 2 is 5. I like to draw a line down the middle. Wish I would have left a little more room, but oh well. To find the Q1, that's the median of the front half. There are 8 numbers on either side. So when we take the median of the front half, again, we're going to have 2 in the middle. I like to slash them out the other direction. Here's the median, or here's the median of the front half between 2 and 3. So we have to average 2 and 3. 2 plus 3 is 5, divided by 2 is 2.5. And then you do the same thing with the Q3. Two middle numbers are both 6, so that means the Q3 is 6. Okay. Then we want to draw a box plot. So again, we make a number line. Make sure we have equal intervals. Smallest number is 2, biggest number is 12. You can go by 1s, you can go by 2s. Those are probably the two best options. I'll just go by 2s. 2, 4, 6, 8, 10, 12. Did not have to do that. Again, the goal is 6 to 12 marks. The box is made up of the 3 quartiles. A mark at 2.5, a mark at 5, and a mark at 6. That makes up the box. You do not have to label them, but I will label them again, just so you know where these numbers came from. The Q1, Q2, and Q3. And then we draw our whisker to the biggest and smallest number that are not outliers. Again, we have not talked about outliers yet. Now is probably a good time to talk about it. So we will come back to this in a second. An outlier is a data point far away from the main body of the data. That's a broad definition, but obviously what does far away mean? Is 5 far away? Is 10 far away? So we need a better definition. We have a formula for the upper boundary and the lower boundary. For the upper boundary, Q1 plus 1.5 times the IQR. The IQR refers to the interquartile range. Find the interquartile range, that's just Q3 minus Q1. All right, so in this problem, the Q3 was 6 plus 1.5. The IQR would be 6 minus 2.5. That's 3.5. And a calculator can help me out with the rest of this. Here's the calculator. 6 plus 1.5 times 3.5 is 11.25. Now what that means is any number higher than this is an outlier. Any data point higher is an outlier. So if we go back to this sheet, 12 is higher than 11.25. So 12 is an outlier. We will draw the whisker to the biggest number that's not an outlier. 8 is not bigger than 11.25, so that's where the whisker is drawn. For the outlier, we make a different symbol, usually a plus. Now we have to check the other side, even though it's probably obvious that 2 is not an outlier, but let's show the work anyways. For the lower boundary, the formula is almost the same. Q1 minus 1.5 IQR. The Q1 is 2. The IQR is still 3.5. And this will give me a negative number. I'll let the calculator do it again. 2 minus 1.5 times 3.5 is negative 3.25. So any data point less than this is an outlier. Any data point lower is an outlier. We will never see negative data points in this class. So there is not an outlier there. So going back to my box plot, we will draw the whisker to the lowest number that's not an outlier, which is 2. So the box plot is all done. Third question, find the range and the IQR. Well, the IQR we already found. That was Q3 minus Q1. 6 minus 2.5, which is 3.5. The range is just the max minus the min. Twelve minus 2 is 10. Letter D. Find the percentage data less than 3. To find that, we find how many numbers are less than 3 over the total amount. There are 16 data points, so 16 goes in the denominator. Now I need to count how many data points are less than 3. There are 4 of them. 1, 2, 3, 4. To make it a percentage, we times it by 100. And that would be 25%. Is less than 3. All right, let's do another example. These numbers are in order already. If they weren't, you would have to put them in order. There should be 20 numbers. 3. Uh-oh, looks like I missed one. There's supposed to be 2 9s. Sorry. All right, so now there are 20 numbers. Good. All right, let's make the box plot. Now, in order to make the box plot, you need to find the 5-number summary. All right. The max and min maybe are not that important to find, but I'm just going to do them anyways. All right. To find the Q2, again, that's the median, so we can do the slash method. Since there are 20 numbers, there will be an even number in the middle. 8 and 8. Obviously, the average would be 8. Draw the line through the median. There should be 10 numbers on both sides. Good. And then we find the median of the front half. Again, since there are 10, there'll be 2 in the middle. 6 and 6 obviously makes an average of 6. Then we do the back half. 10 and 10 make the average 10. Now, we do need to look for outliers, so we have to find the IQR, which is Q3 minus Q1. 10 minus 6 is 4. Upper boundary, again, is Q3 plus 1.5 times the IQR. Q3 is 10 plus 1.5 times 4. That's going to give you 16. So any number bigger than 16 is an outlier. 17 is bigger than 16, so 17 is going to be an outlier. Again, it doesn't look like there's an outlier on the other side, but I don't want to guess, so let's check it out. On the lower side, it's Q1 minus 1.5. Q1 is 6. IQR is still 4. That's 0. There is no number less than 0, so there is no outlier there. So we can make our number line. 1 to 17. Again, you could go by 1s, 2s, 3s, whatever you like. I'm going to go by 2s, starting with 1. 1, 3, 5, 7, 9, 11, 13, 15, 17. Usually on the IV test, they will have the intervals done for you. The box is made up of the 3 quartiles. A mark at 6, a mark at 8, and a mark at 10. Then we draw our whiskers to the biggest and smallest number that are not outliers, which would be 1. Since 17 is an outlier, we go to the next number, 14. That is not bigger than 16, so we draw it to there. There could be more than one outlier. Usually we don't see more, but there could be. And then we make a plus at 17. That is the first lesson. Okay, lesson number 2. Cumulative frequency graphs. This would be 20E. All right, definition. A percentile is the score which a certain percentage of the data lies at or below. So if you're in the 90th percentile of your class, that means you are better than 90% of the students in your class. So the 90th percentile is the score which 90% of the data lies at or below. When there's a tie, there's a method that you use, which we don't need to learn in this class, but in a upper level statistics class, you'll get in more detail with what you do with ties. Let's recall that Q1 is the 25th percentile. Q2 is the 50th percentile. And Q3 is the 75th percentile. All right, let's go to an example. I'm going to make a chart. Finishing time. Frequency. And cumulative frequency. This is some time where the longer it takes, the better. So this is not a race. So the smaller time is not as good. Whoops, getting a little sloppy there. This table does go for a little bit, so I'm going to start abbreviating after this. Most of the rows go up by 2, so I'm just going to use quotations. 30, 32, 32, 34. So again, there's still 2 hours, but just to save some time, I'm just going to use the quotes. 34 minutes to 36. And this is going up to 40, and then it jumps. Move this up a little. I'm going to write a little smaller just to get this all in here. Then at 40, it jumps to 48. And then the last one is from 48 to 56. Okay, so those are the times. So this last one would be 2 hours, 48 minutes to 2 hours. Whoops, not there. 2 hours, 56 minutes. And again, we're saying the bottom time is the best time. So whatever the contest is. And this is how many people finished in these times. So all of this is given. Oops. I was going to say, I thought I missed a number. 5, 8, and 6. So the cum frequency is where we just add the frequencies there. So the 8 just comes across. Then we're going to add 8 to 3 to get 11. We're going to add 11 to 9 to get 20, and so forth. 20 plus 11, 31 plus 12, 43 plus 7, and so forth. And there were 69 people altogether. All right, so the first question was to make the cum frequency graph, which we already did. The second, so question A was make cum frequency column. Question B, let's say make cumulative frequency graph. All right. It's a little harder to make this graph on the x-axis because the time is big. So what we usually do is we change the x values to much smaller numbers. So we usually say the finishing time after the first number. So finishing time after 2 hours 26 minutes. And we will use the first numbers in this graph. The other week we used the average of the two, but we can also use the first one when making the cum frequency graph. So then the first data point is actually our 0. Then 28 becomes the 2, 4, 6, 8, 10, 12, 14, and then a big jump to, that would be 22. All right, so I'm going to go by 2s up to 22. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. It's good to make sure they're equally spaced or this will not look as good.